Hello and welcome to this session where we're going to start applying the KTPA methodology on the case of oil all over the floor in an attempt to help build excellence in your problem solving skills. My name is Arun Singhal. As you know, I'm your management coach and mentor with 40 years of experience in people development. So what is the purpose of this module? The purpose of this module is to help you show you how to apply KTPA methodology to help you build excellence in your problem solving by finding the root cause. And in the 6-step process, which I have compressed here for 5 steps, at the end of this module, we will just focus on the first step of stating the problem, right? And then in the second module, we will look at the second step, the third module, we'll look at the third one, and the remaining 3 steps we will look at in the fourth module of application. So the case that we're going to run through and apply this methodology is the familiar case of oil leak in the filter house, and you are a major food processing company making oil from corn and soybean. There are 5 units that filter the oil, are located in one building. You are the plant manager, and a problem is noticed, and your foreman rushed into your office and say, "Hey sir, ma'am, there is oil all over floor in the filter house." And so the question is, how would you do using the KT problem analysis? How would you find out what is the root cause? And let's look at, before we get into this, let's look at the methodology. So this is a 6-step methodology in which we're going to look at applying the first step or stating the problem, in which we'll state the problem by drilling it down to the level where the cause is unknown, focus on one deviation at a time, and state on what is versus what it should have been, right? So that's the definition of a problem we're going to say. So what is the problem? Let's start stating the problem. You guys want to go back and look at that case and see what is the problem? Define on a sheet of paper. Take 5 seconds, 10, 15, 30 seconds. Note it down. So what is the problem? Okay. So the problem is... if we start stating the problem, the first thing that comes to our mind is the problem statement could be there is oil all over the floor of the filter house, because that is how the foreman told us, right? So we will probably define this as there is oil all over the floor of the filter house. The question is this the right statement of the problem? How do we know? So the thing is to start applying the steps of the process. So let's drill down to the level where the cause is unknown. So let's ask this question. Do we know why is there oil all over the floor of the filter house? So if the foreman came and told you, if I were the plant manager and say, "Hey, John, so tell me, why is there oil all over the floor of the filter house? Do we know the cause?" And so that is the question I will ask. So let's drill down to the level the cause is unknown. So let's apply this step of drilling down and ask questions. So what is the causing the oil all over the floor? And John would reply and say, "Hey, Arun, the number 1 filter is leaking the oil and that's spilling all over the floor." So what we see here is the first statement problem that we defined. That the cause is unknown. So we need to go to the next level where the cause is unknown. Then we will say, okay, do we know why the number 1 filter is leaking oil? And John says, "Arun, God heavens wish I knew that. We have absolutely no idea. Don't know for sure, but we have many guesses." So we now know that we have reached to the unknown cause level. So we have a better definition of the problem in saying number 1 filter is leaking oil. Is that all? So let's check the second thing. Are we focusing on one deviation at a time? And the answer is yes, we are. We are focusing on one problem at a time. And there we are seeing that it is one deviation of number 1 filter leaking oil. So there is one object and one deviation. So that fits in, that says we can emphatically say yes, we are focusing on one deviation at a time. Let's look and ask the third question. Are we stating what is versus what it should have been? And there, if we look at that, we find that answer is really no, because what we are stating is number one filter is leaking oil. Imagine if number one filter was supposed to continue leaking oil, then is that a problem, right? So we need to put in what it should be. So the revised problem statement then finally could be number one filter is leaking oil when it should not be. So that becomes our definition, a right statement of the problem. So you see how important, how different can be the final revised problem statement from the one that appears on the surface, that there is oil all over the floor of the filter house. And we saw that. We knew the cause of that, so that is not the right statement. While we were focusing on one deviation at a time, and the original statement, though revised, also did not have what is and is what should have been the stage also. So the final revised statement we will use and put it on a worksheet as number one filter is leaking oil when it should not be. So what did we learn in this module? So what we learned in this module is, in a case application of the oil all over the floor, that the problem statement as stated us apparently may not be the right one, and we need to apply the 3 steps of the process to go to the level where the cause is unknown, focus on one deviation at a time, and include in the problem statement what is the state versus what it should have been, right? So what are we going to do in the next module? Obviously, next module we go to the next step. Having defined or stated the problem, we will get into specifying the problem. And we will specify the problem by stating what, when, where, and how much is the deviation for the same case. Ready to do that, guys and girls? Wonderful. So thank you so much for watching this video on the application of part 1 application of the KTPA to oil all over the floor. I hope you started getting a feel of the real application of the KTPA methodology, and you are continuing to enjoy this methodology and learning something in the process. So look forward to seeing you again in the next module, where we will go to the part 2 of describing the problem.